Welcome to my presentation. In this presentation, let us see how to find the dot product between two vectors. In here, if we have u as a vector, and if the components of this vector are u1, u2, u3, all the way to un, like that. And then if v is another vector, and if the components of this vector are v1, v2, v3, all the way to vn, then u dot v, read as dot product of u and v, or we can also read that as u dot v. This is called the dot product. Is given to us as u1 v1 plus u2 v2. We're going to multiply the first component of the first vector times the first component of the second vector, and then we keep going till we exhaust all the components of the vectors. u1 v1 plus u2 v2 plus u3 v3 plus all the way till un vn, like that. Okay, so the dot product is a scalar quantity and not another vector. The dot product is always a scalar quantity, not another vector. So just to reinforce what we have seen here, let us take a simple example. Let's say if u is a vector, and if the components of this vector are 1, 2, and if we have another vector v, if I have a vector v, and if the components of this vector are 3, 4, just for a simple example's sake, if we want to find the dot product of these two vectors u dot v, how do we do that? 1, 2, those are the components of the first vector, and then 3, 4 are the components of the second vector. Therefore, we're going to multiply them out. 1 times 3, we take the first component of the first vector and then the first component of the second vector, multiply them out, plus we're going to take the second component of the first vector times the second component of the second vector. Therefore, when we simplify this, 1 times 3 is 3, plus 2 times 4 is 8, and therefore 3 plus 8 is equal to 11. So therefore, this is a scalar quantity. This is a scalar quantity. The dot product of two vectors is going to be a scalar quantity. It is not another vector. In my next presentation, we shall look at some more examples to see how to find the dot product between two vectors.